Am I audible? Is my voice clear? Any issues?
It is clear, ma'am.
Okay. So, as we have discussed in the yesterday's class, what is machine learning and what are the different types in the machine learning? Right. So, can anyone tell me, like, how many types we are having in machine learning? We have discussed three types. Yeah, we are having three different types of machine learning techniques, right? So, what are those? Yeah, supervised, unsupervised, and reinforced. So, if you have seen these all three, what is the main what is the main ingredient that differentiate these three? Yeah, input data. The data is the key ingredient that differentiate these three, right? So, how we can say supervised learning has some structured labeled data. The coming to unsupervised learning, we have data, but it's not in a structured manner, right? In the supervised learning, we have structured data. We have data, but in a structured manner, so it can be directly given to the machine, right? So coming to unsupervised learning, we have data, but it's not in a structured manner, or it doesn't have any labels. So it simply has the data. So from the data, it has to learn. But coming to reinforcement learning, it doesn't even have data. So it itself has to create its own data based on how it has created whatever the algorithm it has inside it. So to that algorithm, it has to create its own data. So that is what the difference between these three, right? Yeah, agent based on the environment. From the environment itself, it takes the data, like what is what what I have to do, like what, when, how, everything it creates itself, right? So that is what up to that. So today we are going to discuss like what is supervised learning, what are the subcategories of supervised learning, and from that one topic we are going to discuss. So can you define supervised learning? So can you define what is supervised learning? Learning from labeled data. Okay. 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 I have said something other also, which have labeled data and okay, a single word. Yeah, yeah. Raju Guram. You have said that it is under supervision. So that is what this supervised learning means. Okay. Supervised learning, it is a type of machine learning where the model is trained using labeled data, meaning in the input data is provided along with the correct output. Okay, that is what the definition of this machine learning, right? Supervision. That's what. So in this, coming to this supervised learning, so in this we again have some categories in the supervised learning. We are using label data. So we are using label data, but using label data also we can do different categories. So one type is classification and the other type is regression. Okay, that is the those are the two different types of uh, categories in the supervised learning. So I think most of you know what is classification and most what is regression, right? Classification and regression. These are the two different types of supervised learning. So we'll discuss what is classification and what is regression. Coming to classification, as we have discussed some example yesterday. So in the bunch of cat and dog images, whenever I have given a new image, it classifies it like whether it is a dog or cat, right? So classification means it is having like it is going to classify things, like it is going to tell something that belongs to some other. So it classifies if we are having two groups of people. So they are combined. So using this classification, we can differentiate those two groups of people. See, to differentiate things, to differentiate two groups or many groups, we use this classification. Okay, it is used to classify things, to say whether an object is belongs to this group or that group. So at that time, at that uh, situations or problems where we have to predict the categories, what type of category does an item that has given belongs to predict that such type of different categories, we use this classification. So coming classes we'll discuss the types of classifications, etc. So today we are going to discuss the other topic, which is called regression. So as you have seen, classification means it is predicting the categories, like whether it is a cat or a dog. So that is what it is predicting, what type of category does the picture belongs to, right? So, but coming to regression, it is not predicting about the category. So it is not a predicting about category. It is like it is predicting a continuous value. So for suppose I will give you an example for regression also. Uh, if you see soda or like cool drink, soft drinks, soft drinks or ice creams. If you see there is some XYZ companies that is producing this ice creams and soft drinks. Okay, so if you see the sales in the town is different than the sales in the city, and that is different than the sales in the village, right? So According to the village, the sales goes. According to the city, the sales goes. According to the town, the sales goes. Right? And not only that, there is another factor, the season. So whenever we are having summer, the sales of the soft drinks and ice creams is more when compared to this rainy season and winter season, right? So depending on the season, depending on the area, the sales are different, right? So that type of data means the previous year's data, which month, the month, and the place. So based on that, it is having some sales number, some 10,000 or some XYZ number is there. Some particular area, some particular month, some particular value. It is changing for every single area, for every single month, right? So that type of data will be given to the machine. Whatever the regression mission we are doing, that is given, this type of data is given, and that is trained. Okay, now what is the task of this regression model is to predict what is the sales that is going to be. So if you ask some particular month and some particular area, so for suppose if we take what is the sales that is going to be in Hyderabad in the March month, like that. If you ask, it calculates whatever, like it predicts from the data, whatever it has learned, whatever the data I have given, from that data it learns some pattern. So okay, on the past year, in the past year, at the March month, we are having that much, like some amount of sales. So comparatively, is the sale from the March to now February is increasing or not? So based on that increase, or based on that, maybe if there is some decrease in the sales in the Hyderabad, so based on that particular thing, it predicts what might be the sales in this March. Like that, it predicts. So if you take some Bombay, some Delhi area, so based on the area, the sales will be different, right? So that is what to know the continuous value, that the regression meaning is to predict a numerical value, we use regression. That is what I want to discuss. To predict a numerical value, we use regression. To predict some category, like whatever the category it has, like to predict some category, we use classification. But we had, like, if you are going to create a model in the classification or model in the regression, you must give a label data. That is what it is important. You must remember, if you are going to create any regression model, you have to give a labeled data. If you are going to create a classification model, you have to give a labeled data. So if you can see what is labeled data in this classification or regression means, in the classification itself, I have said there is some particular column name called what is the color of the eye, what is the shape of the eye, what the eye looks like, and also you can see there might be a column called how the shape of the ears of that particular animal, like that. We are having some names to that uh, data. And coming to this regression, as we have discussed, the month, different months and different areas, right? So that is what we have given the data, but it is in a labeled format. So that is how it can learn. So particular March, particular November, particular May, like that. It, if you ask, it goes to there and it checks. So what it is, if we use the labeled data for the classification, it is used to class, like predict the category of some particular thing. Coming to regression, it is used to know or predict the continuous value. Is it clear? Are you guys still having some doubt on the classification and regression? If it is clear, give me thumbs ups. What Riyaj? What regression? Are you still having some doubt? Uh, See, if you are having uh, some problem where you have to uh, divide a bunch of things into different categories means where you can simply know the simply know the structures. Okay, then we use this classification. Okay, where you need to pick and put it into the another bucket. I will show you. Is the screen visible? Okay, so you are having a plate. In that plate, you are having star, uh, square, and a circle. So in this data where you have given, you are having stars, so squares, and also circle. So related to that particular things, you are having some data that is given to the model. So when you are using this classification, so it is like to put the stars into one particular bucket that is related to stars. So you are putting the circles in one particular bucket that is related to circle. So you are putting a square in some particular bucket that is related to squares. Yeah, specific data. So I am not saying what is what. So like that, what is the shape, how it looks like. So that might be data. So the task of the classification is to segregate, like to put whatever the data into related bucket. That is what this classification means. If I am having another star here, another square, another circle here, and another square here, so what classification does is it puts the square into the respective bucket. It puts the circle into respected bucket. It puts the star into respected bucket. This is how the classification works. Okay, it's clear, right? Divyansh, what is your doubt? Okay. So is it clear what is classification? Clear, right? So this is how this classification. We'll see what is regression. So regression means what example I have explained, sales, right? So okay, we'll take another example. There is a student. Okay, there is a student. We'll take this as a student. So he is studying for the exams. So he is studying for the exams. At the first attempt, he only studied for 1 hour. Okay, he only studies for 1 hour. He got only 10 marks. Okay, at the second attempt, he studied for 2 hours. He got 20 marks. So for the third attempt, he studied for 3 hours. He got 30 marks. So what does it mean is whatever how much he studied, how much time he like used to study, that much marks he got, right? So if he decreases his the study hours time, means it his marks also reduces, right? So depending upon the number of hours he is studying, the number of marks are increasing respectively, right? So there might be some students. So if the second student he studied for 1 hour only, but he got 20 marks. If he studied for 2 hours, he got 40 marks, or you can say 30 marks. For 3 hours, he got 40 marks. You can think. So based on whatever the data it is having, it will predict. Okay, we can say what is the result if he study for 4 hours. We can ask what is the result if we study for 5 hours. Okay, if we ask like that, means it based on whatever the data we have given to the machine. Based on this data, it will predict for the 4 hours. Based on this data, it will predict for the 5 hours. That is what to predict a numerical value, this regression works. Okay, it is it good now? Is this example is good, clear? So now we need to so that is what the definition of the classification and regression, right? So now we are jumping into regression and its type. Okay, regression and its type we are going to discuss. So in the regression, we mainly have three different types of regression. One is linear, and other is multilinear and polynomial. Okay, we are having mainly I'm saying mainly three types of regressions. So one is linear regression, another one is multilinear regression, and the third one is polynomial regression. So what is the definition of the linear regression is the name itself. The linear regression model finds the relation between one independent variable and one dependent variable using a straight line. Means, so as we have discussed in the example, what is the definition I have said? One independent variable and one dependent variable, right? So what does it mean is So this is what the example I have said. So this is the independent variable and this is the dependent variable. Okay, it is the independent variable. So you can study for whatever the hours you want. So based on that, the number of hours only, the result is depending, right? So this is independent variable and this is dependent variable. Why? The result is depending upon the number of hours the student is studying, right? So that is what this linear regression means. Okay, the linear regression model, it finds the relation between one independent variable and one dependent variable using a straight line means. So it is forming, you are forming a equation. Okay, what is the equation means? Y equals to mx plus c. Mx plus c. This is what the formula, like whatever the mathematical equation we use for linear regression. Why we are using mathematical equation means we are we are predicting a numerical value, right? In the regression we are predicting numerical value, right? So for that we are using this mathematical equation. So for this linear regression we are using this y equals to mx plus c like equation to find the numerical value for the linear regression. So in this, what y means, if you see this equation, y means whatever the output we want, like what is the predicted output we want, that is what y. So coming to m means whatever the slope. Slope means in the linear regression, the slope will be linear, means a single line, as we have said, a straight line. So coming to x means whatever the inputs we are giving, that is what the x. And the c is intercept. Okay, based on this, this is the, like if you see the result in our example, the result is known as y. M is whatever the slope, the straight line. In the linear regression, the slope is straight line. And the x is what? The number of hours he is studying. Yeah, the number of hours he is studying, that is known as x. Okay, and coming to c is intercept. It is like it is a value that will be added. Okay, there is some case where we have the inputs as 0. So we must have some value for the output, right? So for that purpose, we use this intercept. That value is like between 0.1, like that. The value is more small, but it is going to be added. Why means there is some cases where we have a null input. So there we can't have like risk, right? So for that we use an intercept value. So this is how you use the you use this linear regression equation to find a relation or numerical value. Okay, and where we'll use this we'll use more this linear regression means. So to predict, as we have discussed, to predict the study hours based on, like to predict the marks based on the number of hours he study. And also you can take an example called the fuel you have used. And you can see for a car, if I used 1 liter petrol, it only goes for up to 15 kilometers, right? So based on how much fuel I'm having, I can calculate the number of kilometers it goes. I'm roughly saying not only 10, 15, they may be go 20 kilometers also. So based on the fuel, we are predicting the distance, right? So based on the salary, sometimes if he's having a package called 20 LPA, you can simply say, okay, might be he has some 5+ years of experience. You can say, right? To further, based on the package, you are saying the number of like experience, right? So based on the fuel, you can say how many kilometers you can go. So based on the steady hours, you can predict the marks, right? So one is independent variable, that is, and another is dependent variable, right? So those type of conditions we can use this linear regression. And you can also have some doubt when these are the example, when should we use this linear regression, you can also have this doubt, right? These are the examples, real time example where we use this linear regression, but you can also have some doubt when should we use this linear regression means. So only one feature is depending on the one feature, another feature is depending. Okay, based on only single feature and output is depending means, then we can use this linear regression. Okay, based on one thing only, not so many things. If one thing increases, another thing increases. If one thing decreases, another thing decreases. At that time, at that situation, if one thing affects the other thing, then we'll use this linear regression. Okay, the if you see this regression, like this relation, say if one increases, the other is increasing. If one decreases, the other is decreasing, right? So the relation is, if it increases, it increases. If it decreases, it is decreasing, right? So it is in a linear manner. So if the relation appears linear, if one thing does, the other thing also affects means, that is a linear relationship, right? So there you can use this linear regression. So these are the situations where you can use this linear regression. Okay. And why we are using this regression, like linear regression means it is simple, right? If we see the examples, or if we see the situation where we are using this means, this is so simple to implement, right? And also it is easy to understand. We are seeing one thing is increasing, another thing is decreasing. So by using this formula where y equals to mx plus c, that is also very simple to put values and to calculate, right? So it is so simple to implement. It is so easy to understand, right? And this is not so complex. So the machine also can it can also learn fast, right? So that is why we are using, yeah, directly proportional. That is why we are using this linear regression in the situation where the thing one thing only affects the other. That's why we use this linear regression. We are having linear regression, right? We have some situation where we can use this linear regression. But also why we are having linear regression, that is fine. Why we are having this multilinear regression and polynomial regression? Why means there are some limitations, right? So if we are having some limitations only, then we are inventing some other, right? So the if you see that this linear regression also having some limitations, so that's why we have created this multilinear regression and also polynomial regression. What are those limitations means? It can't find the curves, so it can't capture any curves. It only capture the relation where it is linear only. So at some situations only one thing is linear, like it goes in a linear manner, right? So there are some situation where the relationship is not in linear manner. So to find out, to know that type of situation, we need to create some other regression model. So that is one reason, and it can't handle multiple factors. As we have discussed, it only uses a single factor, right? So one factor is affecting the other factor. So if it is having more than one factor means, uh, so it can't be implemented, right? So those problems cannot be done by using this linear regression. So that is another problem. And if you see outliers means, so some problems where it has a very long distance between the points. Okay, as we have discussed, this example steady hours, there might be some times where there is no relationship between these factors. So there it can't find. We should know that means. So you are having a data. So this is where you are having data, and sometimes you are having data at this particular point also. So you can find this range only. So you can find linear regression by using this range only. So you can't find a linear regression like value for this particular area. So it is having some range restrictions also. That is why we are using other types of regressions also. So these are the limitations why we are using this other types of regressions also. So like we have discussed, multi-factors mean the example, same example I have given. 1 hour of study is giving 10 marks, right? The student that he doesn't have only one study only, right? He has to have some health, he has to have some sleep, attendance, everything, right? Student doesn't have only study hours, he also have some health, he also have some sleep schedule, he also have some other activities. So at that time, if you are mentioning all those things also, so if you are mentioning all those things, you can't find a linear regression, you can't find some equation, or you can find the marks using the linear regression, right? So that is why we are using multilinear regression. So that is the topic. So now we are going to discuss multilinear regression. It is also linear, but it is having so many different factors. So up to now we have only having one factor and the output. Based on this factor, we are predicting the output. But coming to this multilinear, the relationship is like the relation is linear, but it is having number of factors that is giving, like that is producing the output. So I think you understood what is multilinear regression. So we are having different inputs to predict one output. Up to now, we are having only single input and we are predicting one single output. So you can take each factor is contributing itself to predict a value, like to predict a output. So for this multi-linear regression, the equation will be like as it is. Y means the predicted value, whatever the value we are going to predict, that is what. And you can say A naught. A naught means the first input plus A1. A1 and X1. A1 and X1 means, wait a second. So A1 and X1 means whatever the second input, and we are indicating the like the position of the input. The value it, the X represents the number of the number of that input. So it is the second input. So plus A to X2. So A is the number of the input and X is the value of the input, right? That is what Y means the output, A means the value of the input, means the number of the input, and X means the value of the input. And so on, how many inputs we are having, that many you can write. So that many inputs you can take. Okay, this is what this multilinear regression. Okay, for suppose where we use this multilinear regression means, so you are planning to take an house for a rent. Okay, if you are seeing an house for a rent means you will check what is the floor of the house, whether that house is in the ground floor or the first floor or the second floor, like that. You will check what is the floor where the house is located. So that is one input. Okay, and the second input, what is the size of the house, how many square feet or how many acre, like acres is the house built in, like that. You will check the size of the house, right? And that is the second factor, like that is the second input. And the third input, how many rooms are there, not a kitchen specifically, how many rooms are there, that is a third input. And fourth input, you can take whatever the requirement, how many bedrooms are there, how long the kitchen, like your wish, you can put how many factors you want, how many inputs you want to give, that many inputs you can give based on all things. If the house builds in a ground for that, and that is big in, say, like square feet, and that also have some 3 bedroom flat, the rent will be high, right? So the rent will be varies from the ground floor, first floor, second floor, and the last floor. And the rent will be differentiated between the like single bedroom, 1 BHK, 2 BHK, 3 BHK, right? So, and also the length will be different between the square roots, like square feet, right? So every factor, like every input is affecting the rent, right? So whatever the input is changing, it is affecting the value of the rent, right? So that is where it is in a linear relation only. So if one increases and one decreases, automatically it is representing one rent value. It is affecting one value only, rent value. So that is where this multilinear regression applies. Is the example clear? Simple? Thumbs ups? Are you having any doubts? Arush, wait a second, 1 second. Akila, that logistic regression, the name itself have regression, but it is a topic like that is a classification model. It is not a regression model. The name contains regression, but it is not a regression model. Okay, we'll discuss while discussing in the classification models. So, is it clear up to this multilinear regression? So when to use, you should know the when to use this multilinear regression, right? So when to use means whenever the output is influenced by the different like different inputs, right? So then we have to use this multilinear regression, and where we need based on, not only based on, there is some cases that we can get output if we are having multiple variables like multiple inputs also, then not by using all those inputs, by using only single input also you can get the output. But to get the best, better, accurate value, accurate answer, you can use this multiple inputs together to get the accurate value. So at that situation where you can get by using the single value, but to get the accurate value, we can use this multilinear regression. So that is where we can use this multilinear regression. As I have given this example, right? You can use this in the rent prediction, you can use this in the weather prediction, marketing sales prediction, and also this sometimes our student performance is also based on the activities we have past participated. Not only the studies, the activities also considered, right? The attendance, the punctuality, the activeness in hours also will be considered to calculate the performance, right? So multiple factors are affecting one thing. What is that? Student performance. So like that, in that situations we can use this multilinear regressions. Okay, why use it means to know the complex relation between the inputs to get a single output. We can use this multilinear regression to get more information about a thing. So at the situations also we can use this multilinear regression, like as I have discussed, to improve the prediction quality. To get the accurate values, we use this multilinear regression. Okay. So, as we have discussed this linear and multilinear, do you think like is adding more features is always good? At the first we have used only single input. So for that I have said that sometimes it is not accurate. So for that reason we are using this multilinear regression model where we use more than one. Is it good to have more inputs to get more, like, to get the input always good? Is the question clear? Is it always needed to have more features to get good result? Yeah, depends on the size of the data set. Yeah. So there is some issue. It is good based the point Jinesh said depends on the size of the data set. It depends. Okay, if you are having large data set, means millions of data set, it might be from some noise increases. Like as we had said, as I have said, some points like some features is not relevant to whatever the features we are having in the dataset. Some features is not suitable to that problem but also there in the dataset. So for as we are adding more features, as we are having more inputs, means some inputs can form this noise, okay, which are not related but also being implemented, like included, it forms the noise. By having that noise in the data set, like that noise in our input, in our process, it can leads to overfitting. Means it learns the unnecessary things, right? The thing it doesn't like, means it can be say the student, we have seen the sleep, diet, and attendance is affecting the marks, right? Does the house he is living is affecting the marks of the students? Does it necessary to know the marks of the student? Does it is necessary how he is traveling to the school? It is not necessary, right? But coming to the data of the student, it can have whatever, what is the house he is living and how he is transporting to the school, particular school or college. But it is not necessary to know the marks of the student, right? So that is what this noise. So by putting that, by including that as input to calculate the marks, it is creating, it is making a process long, but it is not useful, right? So that is what this means. So why I'm telling means, you have to use only relevant feature, like relevant inputs only, okay? That is what, why I am saying this. Why I am saying means, I have to explain what are the outliers also. Outliers means the data which is not suitable for the data, like for the data for the problem we are, like we are at. So that is what. And coming to this, the other thing we have is polynomial regression, right? So up to now we have seen a linear relationship. One thing is dependent on other, or more things are dependent on one thing. So up to now it is going in a linear manner. So this polynomial regression models are non-linear relationships. By adding the powers of the features means, as we have seen this, this equation, if you see, we are having the values of the inputs. These are the values of the inputs, and this is the position of the input, right? So as we are not using any powers, it is going in a linear manner. So that means if you see that graph, means it is going either like this or either like this or either like this. Whatever, it is going in a straight line. So it is going in a straight line. That is what this linear regression or multilinear regression means. But if we have a graph like this, so if you are having a graph like this, to specify the curves, whatever the curves I have shown, to specify these curves in the data, we have to use this nonlinear relationships called polynomial regression. Okay. For this polynomial regression, maybe I can write, yeah. For this polynomial regression, the equation will be like y equals to a naught plus a1 x1 plus a2 x2 square plus a3 x3 cube. So whatever the number of the, like whatever the value position of the input, that will be the power of the power of that variable. Y means to define these curves. To define the curves, we are using the position as the power of that value. So by using that, we are, y means we can define, this curve. That is why we are using this, like whatever square, like power of the value. So that is what this linear regression. So linear regression, we have seen it is a straight line, right? So but many real world example, like real world problems, for suppose if you can see population growth, some years it might be decreases, some years it might be increases. So it is going like, if you can see the population, some year it might be increases, sometimes it might be decreases, sometimes it increases, sometimes it decreases, right? So you don't know definite shape. So at that time, we use this polynomial regression. And sometimes, if you see the market trend, means for suppose sales. If you are having sales in the Mintra, or if you are having sales in Amazon, whenever you are having a sales at a particular app, if suppose if you are having sales at the Amazon, means the more people will use Amazon compared to like Flipkart and Mintra. If you are having sales in the Mintra, the more people will use Mintra other than the Amazon, right? So the graph will be like this, not in a line, but it is in a curves, like curves, right? So that is where this polynomial regression uses to, why, to capture that curves, whatever the curves it is having. So to capture that, this polynomial regression is used. Okay. Uh, as we have discussed, y means, why this power means to show the curve, definite, like to show the curves detailedly, we'll use this powers. Okay. When to use means, can we use linear regression where the things, like where the output or where the values are increasing, decreasing, increasing, decreasing, in not in a linear manner. It is like sometimes it increases, sometimes it decreases. For suppose your heartbeat, it can't be measured with using a straight line, right? So at like that, where it is continuously changing, continuously increasing, decreasing, then we can use this polynomial regression. For suppose the real life example you can see is uh, growth, in the population, and also as I have said, the trend. Sometimes a particular product will be boom whenever it is having sales, or whenever it cost varies. So it is having the sales of something that is continuously changes, like that. uh, we can take the examples. But okay, are you having any doubts now in the polynomial regression or multilinear regression? Any doubts, guys? Okay, if you are not having any doubts, this is what the theoretical part of this regression and what are the types of regressions. Tomorrow, at the starting, we'll discuss the code part of these regressions and also a topic and a classification. A single algorithm in the classification also will complete tomorrow. Tomorrow is Saturday, right? I think Saturday. Uh, might be like tomorrow there will be a single session, but come Sunday you might have two sessions. So okay, we'll discuss in the next class. Okay, if you are not having any doubts means you can leave and I can also leave. Thank you guys. Thank you for this session. We'll meet in the next session. Thank you.